Hey guys, so last class we learned about 4.1, which was the introductory to trigonometry, which is the study of angles. And we talked about how there is a new concept of angles measured in radians instead of degrees. Degrees is what we've learned in geometry when we're dealing with triangles. So let's go back and look at these two special types of triangles that we learned in geometry. The 45-45-90 triangle and the 30-60-90 triangle. If you remember back to these two types of special triangles, if you have a 45-45-90, it's isosceles. So these two pieces here, side and side, they're the same. And then to get the length of the hypotenuse, if you were to do Pythagorean theorem, it would be the square root of s squared plus s squared, which is 2s squared. And then taking that square root, you would end up getting s times the square root of 2 when you simplify that. So that is the relationship among the three sides of a 45-45-90 triangle. For 30-60-90, the relationship among the sides of a 30-60-90 triangle is s, the hypotenuse is 2s, and the long leg is s root 3. A quick way that I remember, for a 45-45-90 triangle, there are two side lengths that are equal, so we have a square root of 2. Whereas for the 30-60-90 triangle, all three side lengths are going to be different, so we use a square root of 3. That's just a quick way of how I remember. So the relationships I just wrote here, labeled above. All right, so looking at those relationships, if we made the hypotenuse, the hypoteni of each triangle 1, how would that change the side lengths, the legs? So if I made s root 2 be 1, in order to get from the hypotenuse back to the side, we would have to divide by the square root of 2, this guy right here. So let's change it up here. We are taking this and we are dividing it by the square root of 2, which would be 1 over root 2. But we know we cannot have a square root on the bottom, so this side length here, multiply top and bottom by the square root of 2 over the square root of 2. This side length is root 2 over 2, and since they are both the same, both those side lengths would be the square root of 2 over 2. This is going to be very important in a little bit, so I can keep that there. All right, for a 30-60-90 triangle, if this hypotenuse is 1, but it was 2s in terms of s, we have to go and look and say, oh, well, to get back to the small leg, which is opposite 30 degrees, we have to divide by 2. So this guy is going to be 1/2. And the quickest way to get to the long leg is to multiply your short leg by the square root of 3. So this would be 1/2 times the square root of 3, which, just to make it a little bit simpler, we're going to write the square root of 3 over 2. Hit pause and please write both the top and the bottom down with the side lengths of our special triangles. All right, so the unit circle. Draw this down. A unit circle is centered at 0, 0, the origin, and has a radius of 1. The standard form of a circle, which we're going to learn in the conic section chapter, is x squared plus y squared equals r squared. That is for a circle centered at 0, 0, and a radius of r. So in this case, 1 squared was 1, so this has a radius of 1. So that's a unit circle. Why do we care? If we notice here, both of our hypotenuse, the hypoteni of each of these triangles was 1, and that is going to relate to the special angles on the unit circle. So looking at this one, 45-degree triangle. I placed our isosceles right triangle, the 45, 45, 90 triangle, on the unit circle where the hypotenuse is 1, because that's the radius of our unit circle here. The length of each of our sides. Our x length here, this leg, was square root of 2 over 2, and this length here is also the square root of 2 over 2. Why do we care? Well, let's think for a minute. 45 degrees. What is 45 degrees in radians? Think back. Radians, 180 degrees was pi, 90 degrees was pi over 2, and 45 is halfway to 90, so what would 45 degrees be in radians? If you said pi over 4, you are correct. So, this coordinate of that point where the 45, 45, 90 triangle intersects with the unit circle is the square root of 2 over 2 and the square root of 2 over 2. Your x value, which is the orange side length there, and the y value, which is the height, which was the green side length of your 45, 45, 90 triangle. So that's where those come. Hit pause and write that down, please. Alright, so now let's take a look at the 30, 60, 90 triangle where our hypotenuse is 1 and it is intersecting with our unit circle here. So notice this angle down here is the one we're focusing on, which is the 30 degrees, but I'm just showing you here that this came from the 30, 60, 90 triangle. So filling in some information here. Opposite the 30 degrees, this side length right here is 1/2, which is the y value. That's where this came from here. And opposite the long side length was 1/2 root 3, which we're just going to call root 3 over 2. And that's our x. So, looking here, the coordinates of this point on the unit circle right here are the side length across from 60 and then the side length across from 30, so root 3 over 2 and 1/2. Let's think back for a minute. We're going to transition into radians as our unit of angle measurement. So 30 degrees, what is 30 degrees in radians? So 30 degrees equals what in radians? Take a minute and convert that. If you said pi over 6, you are correct. You can quickly do pi over 180, and 30 goes into 180 6 times, so pi over 6. So that's going to come in handy when we are dealing with all of the angles on our unit circle, all of our special angles on our unit circle. All right, we could have, instead of doing the 30 degrees, we could have made the angle 60 degrees by putting the short side, the short leg, in the x values and the long leg in our y values here. Why did they make the radius 2? I don't know. I got this picture from the internet and I don't like it, so let's change this a little bit here. So if the radius was 1, let's make this 1. And this would be root 3 over 2, and this would be 1/2. I like that better. I have no idea why they did 2. That doesn't make any sense. Okay, so 60 degrees. We're focusing on this one. We just did this one with 30 degrees. Looking at the 60 degree one, notice just our x and y values change because we're still dealing with the same type of triangle. It's just our angle that we're focusing on the origin is 60 degrees. So notice our x values are 1/2 and our y values are root 3 over 2. So think, what is 60 degrees in terms of radians? If you said pi over 3, you are correct. So when we deal with pi over 3 angles, we're going to be dealing with this coordinate 1/2 comma root 3 over 2. All right, so taking all of our information about the 45-45-90 triangle and the 30-60-90 triangle, both with the main angle being 30 degrees and then 60 degrees flipped, we can now fill in our fancy unit circles here. So let's just take a look. So let's just focus on the left one so we're not overwhelmed here. All right, so in class the other day, when we were dealing with pi over 4, when I asked to graph 3 pi over 4 and 5 pi over 4, I broke up our unit circle into 8 equal slices. Why 8? Because the entire circle is 2 pi. So pi on the top and pi on the bottom. So the pi on the top is broken up into 4 equal slices and the bottom is 4 more, so that is 8. So notice if I made this 45-45-90 triangle, but I could also, if I did 3 pi over 4, this triangle here is also a 45-45-90, and the same for these two bottom ones here. So why does this matter? Because it helps us to find the coordinates of the points here on our unit circle. They are just the reflection of this original coordinate for pi over 4, because it was a 45-45-90 triangle. So all of these are just the reflections of root 2 over 2, root 2 over 2. So in quadrant 3 down here, both our x and y's are negative. In quadrant 4, just the y is negative, and in quadrant 2, our x's are negative. So hit pause and draw this unit circle by itself. Draw in your 8 slices and write your coordinates down. All right, so let's take a look at this one. So our pi over 6, our 30-degree angle was this one, where theta was 30 degrees. But also, if we remember, our x and y values for our 60-degree one were just flopped. I'm just going to focus on the 4 middle ones. So all of these ones here, these 4 are all the same, just a reflection of root 3 over 2 and 1/2. Because all of these, this would have been negative pi over 6. This would have been 5 pi over 6, and this one would have been 7 pi over 6. And notice, when I say 7 pi over 6, I'm saying that entire angle there. So all of them are a reflection of root 3 over 2 and 1/2. So these 4 all go together, the 4 inner ones. I don't know why that was written all the way down there, but it is. And if we deal with the 60-degree angle one, and I'm running out of space, so here we go. The 1/2 comma root 3 over 2. This was pi over 3, this triangle here. So the reflection of that one is this, this, and this, the 4 inner ones for this. So those 4 are a reflection of 1/2 comma root 3 over 2. The way that I remember this is if you look at these two side lengths here, this one's shorter. That's your y value, so that's why 1/2 is in the y. Whereas this little piece is your x value, so that's why the x value is 1/2 for the pi over 3 family. All right, take a minute and draw this down, and then we are going to go through this section in depth together. And do not worry, write down your questions, and we will talk about the unit circle and what the heck this even means and what we're going to use it for next class. I hope you guys have a great day. Thanks.